Hello, everyone. Do we have music lover or musician here? Yeah? Okay. Do people remember the garage band? This thing you can play at the Mac. Yeah, GarageBand. I remember it's a app you can open your Mac and you can make a music out of it, right? So it's a digital audio workstation. Like you can create a song from the app, but that's like a desktop. What if you want to do from your phone or even a website browsers? Is that possible? So during the before this year, it's possible, but it takes a whole team and spend a lot of money, and you need a big team and also a lot of devices. But today, our speaker, Azushi, he's gonna share how is it possible in 2026 you can create your own digital audio workstation by yourself, and how he cross different platform and create this music station by himself. And he also tech music meetup founders in Tokyo. He also long-time lover for the music software tools. Let's welcome Azushi Ino. Thank you.
Thank you so much. Well, that was a great introduction. I sound like a great person. And, well, let me get started. But, did you know that today is 808 day? If you are familiar with some synthesizer or rhythm machine called Rolantia 808, people are kind of celebrating that day, and today is that day. Anyhow, that's irrelevant. My session talk is about design and implementation of the next-gen DAW sequencer engine for desktop, mobile, and web. I could say that in one phrase. Okay, so I'm talking about the DAW, and it's a digital audio workstation, and it's used for composing music or manipulating any kind of audio stuff, actually. And the reason why I'm talking about this one is like, you might be interested in building a DAW because it's doable now, kind of, because there are many, well, not many, handful of usable open source engines, such as Traction Engine or Color plugin host or whatsoever that can help building DAW. And in 2026, either you hate or not, you can resort to AI coding agents. So it used to be like almost impossible to build a huge, massive application like DAW by oneself. But now there are many emerging DAW projects on GitHub right now. So you can kind of do that. And I'm actually doing something similar. And I want to share some experience on building the next-gen DAW engine part. And I had a lot of descriptions that you cannot read in these small characters nowadays, and I would say I put too much in. Apparently I can't speak everything about that. So let me focus on cross-platform thing, plugin hosting part, and some open extensibility part. I promise that I mention everything I put on this agenda. But especially I put design and implementation of this code, but apparently I don't have any time to dive into the actual code today. So let me just link to my GitHub repositories, which is @shieno/UAPMD, which I put all my efforts so far. So my agenda mentions the desktop, mobile, and web. The reason why I put that is that I'm building my audio plugin format for Android called AAP, audio plugins for Android, and I actually have many audio plugins exported from desktop to Android, but there was not a lot, there wasn't any usable DAW or plugin host stuff that I could fully experiment the audio plugin format itself. So I needed to build one. And I'm not going to talk about the audio plugin format itself. I actually gave a session talk at ADC Japan, which is Audio Developer Conference in Tokyo, which just started 2 months ago. And it would be, there would be the one next year. So if you are interested in giving a talk, maybe please have a look at it, and maybe you can be a speaker next year. And so here it is. I have some demo application. I mean, I'm not going to show off anything, but this is a desktop version, and there's a web browser version which is running on Chrome. I'm usually using Firefox, and there's even an Android version. I have some tablets somehow, and everything is running the same application. So let me go back to the slide. And I'm actually not the one who is building the multi-platform things. There is a company called ImageLine, which builds a long-standing DAW called FL Studio. And recently, they have announced the web browser version of it. And they have been publishing the mobile version for many years. So it is possible to do something like that. And an interesting thing about FL Studio is that they are using a language called Delphi, which is a variant of Pascal language, and they are very unique. And also, Apple is building the Logic Pro for iPad, and of course, they have the desktop macOS version. And the good thing about the Logic Pro for iPad is that it can transfer the song project data from macOS to iPad, and so that you can continue your workflow from desktop and switch to iPad, and then maybe you can even continue the track making in the bedroom if you want to. And the next generation is, of course, not only about multi-platform thing. And there are many things like AI integration, and there are kind of two different kinds of AI integration stuff apart from the automated song generation such as Snow AI. The AI integration in DAW is like, one is like MCP integration, so that if the DAW exposes any feature through some scripting feature like JavaScript or whatever, then any MCP client such as Cloud Code or Codex, whatever, can get connected to the DAW, and you can use those AI coding agents to manipulate DAW. I actually have added that feature, but I don't really explain that a lot. And there's another aspect called MIR integration, music information retrieval, which would be useful to, say, manipulate music in more textual descriptional way, like chord, time signature, or say tracks, whatever. And also there are MIDI 2.0 native features integrated into DAW, which is new, such as VST3. The latest VST 3.380 has a lot of MIDI 2 feature stuff. And document event model is, maybe you are not really familiar with that concept, but some software such as singing voice synthesizers requires some offline editing feature. And they are using a feature called ARA, and recent DAW started really integrating this feature. And I want to explain this kind of stuff, but apparently I don't have time for that. So let me quickly skip the multi-platform things. So on the plugin formats, my application supports a desk VST3 and Audio Unit V2, Audio Unit V3, LV2, Clap on desktop. And on mobiles, I support AU V3 on iOS. I mean, it's technically running. I have never tested on device, but it's running on iOS simulator. And on Android, I build my own plugin format, so I support it. I'm sure I'm the only one who actually supports it. And web audio thing. On web browsers, I support some experimental plugin formats called WebClap, which is a part of clap format for web, but with a lot of modification. So on every platform, they have different set of plugin formats supported. The most difficult part about supporting these platforms is process isolation. On usual desktop DAW, everything can run in one single process. So DAW loads those plugins as a dynamic library, and it runs in single process. So if the plugin crashes, everything crashes at the same time. And mobiles are different. Like if you and the DAW is distributed and the plugins distributed by different developers. They have to reside in each application process. And they have to communicate each other using something like IPC, inter-process communication. And web browser is slightly different. If you, they can run, I mean, the host GUI main thread and the plugin GUI thread can run in the same process. I mean, in the same browser process, but the audio part has to run in its own process thread called audio worklet. So they, each of those have to communicate each other. I mean, the host has to communicate each other in between the DSP and main thread, and plugin also does have to do that. And do we have to care about these process differences? And it's most unlikely because there are some software SDKs that usually take care of those. For example, if you build some application for AUV3 for iOS, Audio Toolbox API usually has to handle it. And WebClap, there's a library called WClap host CPP, and maybe you don't really have to worry about that a lot. And it loads DSP on audio worklet and web UI on the main thread. And on AP is my plugin format, and I provide something similar so that app developers don't have to worry about that. But I did have to worry much about that instead of you. And one of the very difficult thing is how to deal with audio graphs. Audio graph is basically a connection of nodes of, say, instruments node, and then usually you use effect nodes and then audio output nodes, and you also have input nodes, and they are connected together. And the audio DSP, audio device runs its audio input I/O cycle in very quick real-time manner. So usually you have to deal with it. You actually don't have to deal with it on desktop, which means like if you are missing the deadline of the audio cycle, the output is slightly delayed, and some professional musicians would notice, but you wouldn't. But web browser is different. The audio worklet kind of forces the real-time cycle, and if you miss the deadline, the output goes silence. And that means like missing audio outputs at all. I mean, for some thread, some slices. So that would result in either noises or sudden silence, which is not good. And creating those audio nodes, like you create some new instance of a plugin, that cannot happen within the audio thread because it involves memory allocation, which is not real-time safe. So you have to deal with everything in non-real-time thread and then swap the entire graph between the real-time audio thread and the non-real-time thread. It's a lot of difficulty over there. And if you want to provide some libraries that provide some flexible audio graph APIs, like you can let developers build any kind of audio node, and then it suddenly becomes difficult because there are some API that you developers still have to implement in real-time manner, and whatever that is not. So it's kind of difficult. And GUI is another difficulty, especially when the processes are separate. The host process and the UI has different, if they are in different processes. it's difficult. The API requirement actually is similar among any different plugin formats. Like every plugin format requires like create UI, show UI, hide UI, resize, and notify resized, whatsoever. And on desktop, everything is kind of easy. Like, I mean, except for Linux, Linux brings in a lot of complexity. But usually on Windows, you can just use Windows API, and on macOS, you just use Cocoa API or Carbon or whatsoever. But on Android, it's difficult because usually you cannot overlay other applications GUI onto the host application GUI. But starting Android 11, they have started providing some API called Surface Control View Host, which makes it possible to render remote UI on another process. So in AAP, my plugin format, I use the host surface view, and then the let plugin render its own GUI, which can be any Android view, and then it is dispatched to the host side. iOS has its own world, so it doesn't matter a lot. And WebClap and AAP actually supports another kind of GUI called Web UI, which is like you, in a host application, you create a web view, and then it simply asks the plugin to retrieve, to give the plugin a GUI resource in HTML or SVG or whatsoever that is renderable on web view. And the principle is easy, but each plugin needs to communicate between the web content and the DSP. Especially on Android, it's actually the same. On web audio worklet and GSRAP process, and for Android, the host and the plugin, they reside in a different processes, so they need to communicate each other by some means. Dealing with parameters is a very basic feature on audio plugin formats, but it's actually quite annoying to deal with if you're trying to implement it. There are 3 players, DAW, and plugin DSP, and the plugin GUI. They are all different players. They hold their parameter values for each. And all of them have to be consistent. And any of those can start changing parameter value. And when one changes the parameter value, it must be dispatched to everyone else. And there are actually a handful of those scenarios I had put as lines, but I don't have time to explain everything, so I just say that there are many scenarios that you have to deal with. Okay, so multi-platform and so one thing I missed is that depending on the plugin format, the way how it has to dispatch the parameters are different. So you have to deal with that in each manner. So how many time do I have rest? Okay, not a lot. So let me dive into generalization and extensibility kind of topic. It's not really cross-platform or anything new for the next gen DAW, but anyhow, I try to build a library that is usable for anyone who wants to DAW. So I wanted to make it as flexible as possible, and at the same time, supporting cross-platform and multi-plugin format architecture is kind of difficult, and we have to commonize some features a lot. So commonizing everything yet flexible is already kind of difficult, and we have to implement a lot of features to get the audio engine really useful for DAW, and adding more features and then code quickly gets complicated. Especially we are like dealing with a lot of AI, and this AI slop can quickly make things unmaintainable. So we have to use AI coding agents carefully a lot and try to sanitize anything. And adding features affect data, song project data format. And if you do that randomly, that quickly results in the backward incompatible data format. So you should be careful about that too. Let me introduce some complexity example scenarios that I had explained. I experienced. I added some audio track feature, which is simple, like you just add some audio clips in one track and then just play it. And then I wanted to add some feature that constrains how the audio clips are connected together. Like if I want to move one clip, everything else can move together or don't have to. And there should be any data format that represent this kind of constraints, but I couldn't find anything, so I implemented everything in privately. And there are audio warp feature. Audio warp is basically like you have, for example, you have vocal track, guitar track, drum track, bass track, and everything just can't fit perfectly. So you have to adjust some lengths of each audio clips. And you have to continuously do that, and that's called audio warps. By doing time stretches, like this part is like run by twice faster, like that. So this is called audio warps, and there's also no standard way to represent that kind of data either. And I implemented the support for DAG. DAG is a complicated graph, directional acyclic graph, which is kind of terminology in computer science. And before that, I only had a simple linear graph for instruments, effects, and outputs. And it was simple, and there's no need for any data. But DAG requires its own data representation. And also, I had to support some complicated arbitrary audio graph nodes. And volumes, and then I added volume slider on each track, and I wondered, where does this audio volume slider exist? Within the audio graph? Of course it should be, but how do I represent the data in the saved format or whatsoever? And latency compensation, it's too complicated. I can't really explain what it is. So if you're curious about that, Google or search latency latencycy compensation, what about that. And track freezing, it's also a difficult topic. And track freezing, it's also a difficult topic, and I will explain that soon. And on flexibility, whenever we want to let developer implement any arbitrary kind of features or extensions, is it doable? And one example case is custom audio plugin, audio graph nodes, like what kind of audio nodes should exist. For example, there's a gain node, the volume slider, and then there can be a channel splitter from stereo to mono to stereo, and then merge things stereo to mono to give some audio effects that only accepts one input whatsoever. And there's also spectrum analyzer, which is usually a graphical feature, but you still have to deal with the real-time audio outputs or to monitor things. So you have to create an analyzer node. They are similarly implemented in Web Audio API as well. So I actually implemented like them as a built-in stuff. And then how it is implemented and what to extend is kind of difficult thing. So I had to add some annotation of some functions so that it has to be handled in real-time safe manner, and this must not run in the real-time thread, that kind of. And data extensibility is also kind of annoying topic. Like basically, you have to tell the plugin graph node developers that you also have to worry about saving and loading the data node, and provided some API. Another complicated scenario is a track freezer. Like the track freezer feature is basically that if you have hundreds of tracks within a project, the engine cannot really process everything in real-time safe manner. So you usually have to freeze many of those tracks that you don't edit. if you edited some tracks that goes unfrozen and then it goes live, but other parts can't. You can't really edit 100 tracks at the same time. You are a human being. You are mostly a human being, I guess, and then you don't really have ability to deal with that. So we freeze tracks, but freezing a track is actually not that simple feature because what's up? Is it back? Okay. Freezing a track is not really easy because you cannot have the instance positioning two positions in a song at the same time because they point different set of parameter values. And if you are playing the music and you make changes while editing, while playing, you need two instances while one for playing and one for freezing. Or the freezing should not happen when playback is ongoing. I took the latter approach to simplify everything so far to avoid cloning two instances of an audio plugin because sometimes the plugin instance can require a lot of memory. So I avoided that, and then I implemented everything in the playback engine first. So it was like if the freezing is in progress, if it's queued, or if it has frozen content. Otherwise, process real time, that kind of stuff within a single audio engine implementation. And notice that it's unmaintainable. It's too complicated. So I changed the model, how I deal with those freezing tracks. As basically, it's now it is an extension to the simple audio playback engine. And then whenever the playback is stopped, any pending freezing tracks can start freezing it. And while it's ongoing, and then user started the playback, any ongoing freezing work is cancelled, and then playback starts, and then whenever the playback is stopped, then freezing restarts again, that kind of. So it's complicated. The feature itself is complicated, but making things adaptable or injectable within the playback engine, it became very simple. Yeah, I said very simple. It's actually not that simple, but it's fairly simple. And regarding the song project data format, basically what we have to save is audio tracks and instrument tracks and some settings. And for instrument tracks, since we deal with a lot of different plugin formats, we will have to resort to some common data format. And a lot of DAWs still use mental model from MIDI 1.0 with better data precision. But now we have MIDI 2.0, so we can simply use MIDI 2.0 clips to represent those track contents. And audio tracks are simple, like you can just have an audio file, and then I mentioned the audio warping, and so just add audio warps. That should be simple. So I thought that this ongoing specification, I mean, there's a draft specification for SMF to container file, which is not public, I guess. But they have some outline in the in this diagram, which was published on the MIDI Association blog post. So I think it is usable. Like you can contain both audio tracks and MIDI tracks, I'd say. And in audio tracks, you can also point resources, audio resources, and then in audio clips. And you can also add some custom metadata. So I can add things like audio graph information, instrument settings, audio warp information within this standard files. And then I only care about how to extend the data format. So basically, it would work. But since this specification is not public yet, so I can't really resort to it. So I define my own my own project data so far, but it would be flexible enough. Okay, so I spent a lot of time to explain everything, so let me quickly wrap up. I have described what are needed and what can be roadblocks for multi-platform, multi-plugin format DAW engine. A plugin format on multi-platform is kind of annoying. Process isolation is annoying. GUI model differences bites us. And parameter consistency is actually quite annoying things. And to generalize things and yet keep open and extensible things, I tried hard to abstract the audio engine away a lot. And I tried to use common data format for additional with additional extension data within for compatible data. So that's all. So if you're curious about what I'm doing, I put the GitHub link here. So if you have time, please have a look at Sheno/UIPMD for this. Okay, thank you so much. And if you are interested in how this application works, I will show you later if out of the stage. Thank you so much.
Any questions? Okay.
Hi, I'm curious. Recently, there is some people talking about using Electron framework. I think it's some kind of Chrome or similar browser plus JavaScript, these kind of things, as a GUI platform. But also, some people talking about these things can be a little bit heavier. But I think for the audio application, latency is most important, critical issue to use any kind of platform or engine. I was wondering whether you have some kind of insight about the choice of this GUI platform in developing the DAW application. Thank you.
I'm afraid I dropped something for the question. I guess you're actually asking the audio part and the GUI part, and the worry about the audio processing stuff, I guess.
Yes, yes.
When it comes to audio engine, the web audio is actually surprisingly designed well for real-time safety in that the audio worklet runs in its own process and its own thread, which means like if you allocate any memory that, if you want to allocate any memory, that must be done outside, and then you can use the shared memory to dispatch the same memory region to audio worklet thread. So usually you can be free from that, and you can avoid, you can write lock-free code for that as well. And when you're implementing the DSP part for the web platform, you can avoid using JavaScript. And you can use WebAssembly, and you don't have to use a garbage collector. So it can be allocation-free in total. And GUI part runs in different threads and process, so you don't really worry about that. And then you can actually use web platform for web technology for building DAW GUI. I don't really know any desktop native DAW that is based on web technology, but on plugins, there are actually some companies that makes use of WebView technology to make it possible. And it wouldn't matter, even if you can, even if you want, you can use some technologies such as Qt or maybe not GTK, but anything like say, I'm actually not sure. Maybe you can use Flutter whatsoever, but you should worry about avoiding GTK something. Usually Linux people are trained to use X11 directory. or you can use the latest Qt with special care about application loops. Does that answer your question?
Yes, yeah.
Thank you.
Hello. So I'm curious about the audio and visual syncing. Did you have any issue like for plugins to sync the visual effects with the audio? Like, I know there's no like a necessity of syncing a visual effect with audio for plugins, but like, did you have any issues like seeing some noticeable lags between the visual effect and audio?
Good question. I haven't worried about that because usually, yeah, as you guessed, synchronizing GUI and audio is usually regarded as in theory impossible, and we just try best to synchronize GUI and audio. And in this regard, web club might not work ideally, but on Android, it would depend on how this underlying surface control view host works. But I guess it's in the underlying technology on Android, surface control view host makes use of the binder feature, which is the kind of fastest engine to dispatch transmits a lot. And if it doesn't work, anything wouldn't work. So, and on Android, I believe it's doing its best. And on the desktop, it's simple. I mean, I'm just running everything, and this application is based on IMGUI, which is almost immediate to render everything. So I think it's best. It's kind of best. And on web browser, honestly I have no idea.
Got it.
Does that answer enough?
Yeah.
Anybody else? All right, thank you so much for our speakers. Thank you.
Thank you.